Assuming that the inductor L1 current is going to rise from I L1 minimum to I L1 maximum in time t1, the voltage Vs is given by L1 I L1 max minus I L1 minimum divided by the time t1. This is equals to L1 delta I L1 divided by t1 equals to Vs, that is equation number 1. From this, t1 equals to L1 delta I L1 divided by Vs, that is equation number 2. Due to the charged capacitor C1, the current of the L1 falls linearly from I L1 max to I L1 minimum during the time t2. Then Vs minus Vc1 is equals to minus L1 I L1 max minus I L1 minimum divided by t2, from which Vs minus Vc1 equals to minus L1 delta I L1 divided by t2, that is equation number 3. From this, t2 equals to L1 delta I L1 divided by Vs minus Vc1, equation number 4. Vc1 is the average voltage of capacitor C1, and delta IL1 is equals to delta IL1 max minus IL1 minimum. Now from the equation 1 and 3, delta IL1 equals to Vs T1 divided by L1, that equals to Vs minus Vc1 T2 divided by L1. This is minus value, so here it is minus value, from which Vs T1 equals to Vc1 minus Vs of T2. T1 is equals to Kt and T2 equals to 1 minus K of T. Vs T1 equals to Vc1 T2 minus Vs T2. Now Vs T1 plus T2 equals to Vc1 T2. Now substitute these values, then you will be getting Vc1 equals to Vs T by T2, that is nothing 1 minus K of T, that equals to Vs divided by 1 minus K, that equals to Vc1. This is the equation number 5. Now, assuming the current of the filter inductor L2 rises from I L2 max to I L2 minimum during the T1, then Vc1 plus Va equals to L2 delta I L2 divided by the time T1. That is equation number 6. And the current of inductor L2 falls linearly from the max to minimum in time t2. The output Va equals to minus L2 delta I divided by t2. Now from this equation, t1 equals to L2 delta I L2 divided by Vc1 plus Va, that is equation number 7. Then this V8. From this, t2 equals to minus L2 delta I L2, this is regarding the L2, divided by Va, that is equation number 9. From the equation number 6 and 8, delta I L2 equals to Vc1 plus Va multiplied by T1 divided by L2 equals to minus Va T2 divided by L2, from which Vc1 T1 plus Va T1 equals to minus Va T2. Then Vc1 T1 equals to minus Va of T1 plus T2. From this, Vc1 equals to minus Va T by T1, which is nothing but minus Va by K. That is equation number 10. Now from 5 and 10, Va equals to minus K Vs divided by 1 minus K. That is equation number 11. Now, assuming the lossless circuit, the input power Vs Is equals to minus Va Ia, as the polarity of the voltage of the output is reverse. Substitute the value of Va from equation number 11. Vs Ia K by 1 minus K. Vs Is equals to Ia K by 1 minus K. That is equation number 12. Switching period T. The switching period T equals to 1 by switching frequency F, that equals to T1 plus T2. From 2 and 4, substitute the values of T1 and T2, then T equals to delta I L1 divided by Vs minus delta I L1 L1 divided by Vs minus Vc1. That equals to delta I L1 divided by Vs of Vs minus Vc1, Vs minus Vc1 minus Vs. T equals to minus Vc1 delta IL1 L1 divided by Vs of Vs minus Vc1. That is equation number 13. Now, the peak to peak ripple current for the inductor L1, that is delta I L1, is given by Vs of Vs minus Vc1 T minus Vc1 L1. That equals to Vs minus Vc1 divided by minus Vc1 L1 of F. This equation number 14. If you simplify by substituting the values of Vc1 in this, then you will be getting Vs K divided by F L1 as delta IL1. That is equation number 15. Now, the switching period can be found from 7 and 9. Then T equals to delta IL2 divided by Vc1 plus Va minus delta IL2 divided by Va. Now, from this delta IL2 take this as a common, then Vc1 plus Va of Va, then Va minus Vc1 minus Va equals to T delta IL2 divided by Vc1 plus Va of Va minus Vc1 equals to T, from which the peak to peak current of inductor 2, that is delta IL2, is equals to Vc1 plus Va of Va minus divided by Vc1 L2 F. Now let this be equation number 16. Now if you substitute the value of Vc1 in this, then you will be getting delta IL2 equals to minus Va 1 minus K divided by F L2. That equals to K Vs divided by F L2. That is be equation number 17. When a transistor Q1 is off, transfer capacitor C1 is charged by an input current for a time t equals to T2. The average charging current for C1 is IC1 equals to input current Is. The peak to peak ripple voltage of the capacitor C1 is given by delta Vc1 equals to 1 by C1 integral 0 to T2 IC1 dt equals to 1 by C1 0 to T2 Is, that equals to Is T2 by C1. This is equation number 18. Then from the equation number 11, T2 is equals to Vs divided by Vs minus Va of F. Now, substituting this in equation number 18, delta Vc1 equals to Is Vs by Vs minus Va of F C1. That is equation number 19. Now, from which delta Vc1 equals to Is 1 minus K divided by F C1. Equation number 20. If we assume that the load current ripple, that is delta I0, is negligible, then delta IL2 equals to delta I C2. The average charging current of C2, which flows for a time t by 2, is IC2 equals to delta IL2 by 4. Now, the peak to peak ripple voltage of the capacitor C2 is equals to 1 by C2 integral 0 to t by 2 IC2 dt. That equals to 1 by C2 integral 0 to t by 2 delta I2 by 4. That equals to delta I2 by 8F C2 is the delta Vc2. That is equation number 21. Now, if you substitute the value of delta I2 from equation number 17, then you are going to get delta Vc2 equals to minus Va 1 minus K divided by 8C2 L2 F squared. That equals to K Vs in terms of input voltage 8C2 L2 F squared. That is equation number 22. These 22 equations are useful while designing the CUK regulator parameters. And this circuit also requires an additional capacitor and inductor. If this video is useful, please like, share, subscribe and comment.